We want to find the best classifier for our problem. For that, we need to know the error it makes. It is common knowledge that to estimate the classifier error, we must compute the error on a separate test set, unused in training. In practice, all we do have is a design set. We may split the data samples randomly, for example 50-50. We train the classifier on one set and evaluate on the other. The larger the training set, the better the classifier. The larger the test set, the more reliable the error estimate. How to combine these opposite needs? The cross-validation is a tool that helps us with that. Let's see how it works. In this example, we want to use a 5-fold cross-validation. We split the design set into 5 folds. We train the classifier on 4 folds, and we test on the remaining fold. We repeat the procedure 5 times. The average result provides our error estimate. The advantage of the cross-validation is that we use all samples to evaluate the classifier, but in an unbiased way. A variation of the cross-validation is called leave one out. Here, we leave one sample out for testing and use all other samples for training the classifier. In this way, we ensure we have the largest training set, and we are still evaluating the classifier on all samples in an unbiased way. Usually, we don't leave out one sample, but, depending on our application, all data of one person, object, or video clip. Let's take an example of human pose recognition. Our goal is to classify 9 different body poses. The set contains data from video sequences of 15 persons. We perform a 15-fold cross-validation to compare different classifiers. Let's start with a simple nearest mean classifier. The mean error is 6%. We evaluate more classifiers. This table summarizes the results, cross-validating over samples, video frames. We would conclude that a complex Parsen classifier is entirely separating all classes. In practice, though, we know that our data has a structure. It comes from 15 different persons. We are interested in a classifier for new, unseen people. How to estimate the error of the classifier in a way that is close to this use? We should perform the cross-validation over persons, not over samples. This means to take the data from one person out for testing and train the classifier on the remaining people. In per class, we can easily do that. If we perform realistic testing on unseen persons, we see that multiple classifiers provide a similar error of about 5%. Based on these results, we will choose the simplest classifier, the regularized linear discriminant. Summarizing, we have learned that cross-validation is a useful tool if testing is realistic, and per class helps you to choose the best classifier for your problem. Thank you for your attention.